Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so we started doing a little bit of this. But we're going to rearrange before we use substitution. So we're going to do the substitution method, the solving systems of equations again. And this might be what you missed. Elkin, I don't know. But we're going to rearrange our equations before substitution. So we'll start with, just to review, we'll start with one that we've already done. So we're going to solve a system of equations. Now, if I just wrote an equation on the board, 2x plus 3y equals 5. How many solutions are there to this equation? How many xy combinations will make that true? Nathan? Well, 1 and 1 works, but look what else works. I could say 1/2 or -1/2 and 2. That would work, because if this is -1/2, that would be -1 plus 6 is also 5. So the most popular answers in math are 1, 0, or infinity. Correct answer is infinity. There's an infinite number of solutions that will make this equation true. Okay, especially when you have, you could say x is 2.5. Right? If x was 2.5, that would be 5. And then if y was 0, so 2.5 and 0 that would be true, right? So there's an infinite number of solutions. So the way we say the solutions is with the graph. Remember that straight line? This is called the linear equation. So that line goes on forever in both directions. All right, but if I put another equation on the board, there's an infinite number of solutions to this equation. This is a different equation. There's an infinite number of solutions to this equation. So that solution is another line. But these two equations together only have one point in common where they intersect, where they cross, right? So that means there's one solution that works for both of these equations, okay? So when we say solve a system of equations, that's what we're trying to find. We're not solving for any x and y. We're solving for the x and y that work in both of these. Okay. So 1 and 1, yeah, that works in that one. Does it work here? 1 equals 2 plus 3. No, so 1 and 1 wouldn't be the solution they have in common. But 1 and 1 works in that one, but it just doesn't work in this one. So you could, theoretically, you could just try to think of numbers that would work until you get the right one, right? What was another one we had? -1 and 2. So let's see, -1 and 2. So that would be 7. If that was 2, that would be 7 equals -1. Nope, that doesn't work. So the way, there's one method that we've learned so far, and that's called the substitution method. So remember we talked about the substitution where if two things are equal, you can substitute one for the other at any time. Okay, if Elkin had a clone, then we could substitute Elkin for his clone at any time. Well, I mean, he's not truly equal to his clone. His clone is a little boring, but it's not, doesn't have Elkin's charming personality. But theoretically, if two things are the same thing, equal, then you can substitute them at any time. Okay, so x is the same thing as 2y plus 3. Remember, this is, x doesn't want to be called x anymore. He got famous, so this is his new rapper name, 2y plus 3. Kind of rolls off the tongue. So basically, this guy, 2y plus 3, can be substituted for x at any time. Anytime we see x, we don't have to say x. We say 2y plus 3. So instead of saying 2x plus 3y, we're going to say 2 times 2y plus 3 plus 3y equals 5. Well, why confuse it like that? Why do we do it like that? Well, this seems like a more complicated equation, doesn't it? But what's the whole point of that? What's the point of doing that? Yeah, now you have an equation with only one variable in it. If you have an equation with just one variable in it, you can solve it. It's not infinite solutions anymore. There's only one y that will make that true. So let's figure it out. Let's just follow the steps of solving equations. Get rid of parentheses, distribute. So 4y plus 6 plus 3y equals 5. Okay, combine like terms. What is that? 7y plus 6. You guys following me? Okay, so now, this is not going to be pretty. So now get rid of the constant. I'm going to use a different color. So 7y equals -1, y equals -1/7. Ew. Okay, so if y was -1/7, how do you find x? Well, we can plug that into x's wrapper name. If this is -1/7, we can plug it in right there. So now x equals 2 times -1/7 plus 3. So that's, what is it? 2 5/7. That's ugly. Okay. 2 5/7. So this is my x and y. This will work in both equations. If you do that, 2 times 2 5/7 is 5 3/7 plus -3/7 comes down to 5. So it's ugly, but it works. Okay, yeah.
Would it be, how does it come to 5/7?
Because you have a -2/7 added to a +3 whole. So you take -2/7 away from 3 wholes. So you have 2 wholes and then +5/7, right? Because a whole is 7/7. But you can find a common denominator and do it the way you want. But that's basically it. Now, luckily, you won't get fractional answers like this all the time. It's going to be much more satisfying. Okay? So now this was nice because x told you what he wanted to be called already. You had an equation that says, oh, x equals this. But this isn't always going to be the case. You might have two equations that look like this, where this doesn't say what x is or what y is. It says what 2x plus 3y is, but that's not really helpful. So basically, we're going to rearrange an equation before substitution if we don't have this gift. This is a gift that they just gave you. Here's what x is. Substitute it anytime you want for x. Okay? It's not always going to be like that. So let's do an example where it's not like that. All right, so here's my next example. System of equations. X minus 2y equals -1. And then 2x minus 3y equals 4. So I want to solve by substitution, but there's nothing to substitute. It doesn't say x equals this or y equals this. It just says these equations. So our first step is to get one of these 4 variables by itself. Which one looks like the easiest one to get by itself? Top left, top right, bottom left, bottom right. Which one is almost by itself? Which one doesn't have any friends hanging all over him? Eliana? Top left. Yeah, look. This one doesn't have a coefficient. So always look for ones that don't have a coefficient. Okay? That's the easiest one to get by itself. All you have to do is get rid of this minus 2y, and then x is by itself. So let's do that. Okay? So the shortcut, do you remember the shortcut of just getting rid of an entire term? What do? Well, you add it. That's not the shortcut, but I mean, it doesn't take much longer. If you add 2y to both sides, then you get -1 plus 2y or 2y minus 1. But the shortcut is, if you want to get rid of a term, not a coefficient, but a term, something that's added or subtracted, just put it on the other side with the opposite sign. So this is x equals a positive 2y over here, and then a -1 or -1. So you could have just said -1 plus 2y. There's nothing wrong with that. And you could have substituted -1 plus 2y into here. There's nothing wrong with that. I just like having that look like, I don't know. Doesn't matter. So this is what we're going to substitute in, right? So x, now we have what x, now this is a gift. X is this. Substitute this in anytime you see x. Okay, where do we see x? Right there. So we're going to put it right there. So how do I rewrite this equation? Elkin, tell me what to write.
2 times 2y minus 1.
Okay, so like this.
Or within the parentheses.
Yeah, so if you don't do parentheses, it'll just be 2 times 2y minus 1. We don't want to say 2 times 2y minus 1. We want to say 2 times 2y minus 1. Hear the difference? You don't, do you? I paused in different places. It was poetic. Iambic pentameter. I think that's a thing. Iambic pentameter. Isn't that like a way to, like a type of poetry? Like dun da dun da dun da dun, dun da dun da dun. You know, like the accents are on. No, nothing. Okay. Mrs. Rember, ask her what the iambic pentameter is. It's really fun to say, if anything. Okay, so but see, this is just x, so we still have to write out the rest of this equation. So see how this is still 2x minus 3y equals 4? Good? All right, now what? Yeah, get rid of parentheses. Start solving for y here. So let's see, 4y minus 2 minus 3y equals 4. Now what? Combine like terms. So I've got this. What does this combine to? Just y, right? 4y and negative 3y. Remember, this minus is not, this only has to do with the 2. So 4y and negative 3y, if it helps, you can do this, right? So you got y minus 2 or plus negative 2 equals 4. Now what? Add 2, y equals 6. Are you done? You're half done. Actually, you're more than half done because the last step is pretty quick. All you have to do is plug that in. I'm going to circle that in red. Plug that in right, where is it? There. So when you got that variable by itself, this is the best equation to find x, because if you can find y, you just have to double it and subtract 1. So double 6 and subtract 1, what do you get?
11.
X equals 11. Now let's make sure this works. So we know it works in this equation, which is really this bottom equation, or the top equation. Let's see if it makes sense in this equation. So 2 times, what's x? 11? 22. See how I got 22? Minus 18. What's 22 minus 18? 4. It works. Okay? Now you could have spent some time trying to figure out those two numbers on your own. That's another method. It's called trial and error. And usually it takes you a long time. But I had a student that survived all of Algebra 1, not learning any of these methods, just trying to figure out numbers that would work. So he would spend a lot of time trying to figure out numbers that could work. And he did. I call it the Daniel method, because he didn't want to learn any of this stuff, because his name was Daniel. So you can do it that way if you wanted to. There's nothing wrong with that. And here's the other good news is if you check these and they work in both equations, this is right. You can do whatever method you want. As long as you tell me what x and y in are, then you're good. You I mean, technically, you don't have to show your work, right? You could just guess and put it in there. But show your work, so just in case you're wrong, I can still give you credit and tell you how you were wrong. I like telling people how they're wrong. Okay, let's do one more example. I'm going to let you guys do this by yourself. This is example 2. Solve for this system of equations. Okay. All right, so I'm going to do a free problem set for the first person who gets this.
First person or any person?
First person, and then I'm going to do a Flack attack coupon for anyone who just gets it. You don't have to be the first one to get it. If you just get it, you're going to get a Flack attack coupon. Do you hear that, Micah? So if you get that first, then I'll give you a free problem set. So hold it up to your camera if you got it right, okay? So be careful. Like, I'm assuming you probably want to get that top y by itself, right? Because it doesn't have a number being multiplied. So when you get rid of the 2x on the other side, you're not left with y, you're left with a negative y. So make sure you negate that y, and if you can, as long as you negate the other side too. So just go crazy with negative signs. If you make that negative y positive y, then just make everything on the other side the opposite sign. Get it? Not quite.
Do you have a calculator?
Yep, you can borrow a calculator up there if you want. Nope. So I need x equals a number and y equals a number. Or you can do what the cool kids are doing and write it like this. Okay? And you should get nice, easy, single-digit numbers on this one, okay? If I wrote it down correctly. I did this time. You're doing good so far, Micah. Finish it. Okay, keep working. What do you got so far?
Which one?
That's so it should be 2x minus 10. So when you put the 2x over there, it's negative 2x plus 10, but then when you make that y positive, then it becomes positive 2x and negative 10. But everything else, and then when you plug it into there, so instead of x, you're going to write, or instead of y, you're going to write 2x minus 10, but it should be 4x minus 3 times y. So everything else is the same, you just replace the y with 2x minus 10. All right, take another minute-ish. Why? I'm curious. So keep trying, Micah. So that's not the right x. So remember when it's minus 3, and that 3 is distributed to the minus 10, so it's actually not negative 30, but it's plus 30. All right. Keep working, but I'm going to have you guys walk me through this, okay? So Audrey got the right answer, but if you get it before I finish, then I'll still give you a Flack Attack coupon, okay? So Zan, can I use you as an example of what you did? So here's what Zan did. So he figured, okay, this Y looks the most vulnerable, the least protected, right? So we're going to go after him, get him by itself. Okay, so what we can do is we can pull this over there. So a 2x over on that side becomes a negative 2x, right? So that's what we have, negative y equals negative 2x plus 10. But we don't want a negative y. We want a positive y, right? So make that positive. So you have to make that whole side, change the sign of everything over there. Or if you want to put a parenthesis there, multiply by -1, you could. But I'm just going to change all the signs. And that works. So really that's 2x plus -10 or 2x minus 10. So that's what we're going to plug in right here. So we're going to rewrite this bottom equation exactly how we see it. The only thing we're going to write different is the y. So 4x minus 3 parenthesis 2x minus 10 or plus -10.
I have an answer now.
Do you? All right, what do you got?
X equals 7, y equals 4.
Yes.
Oh,
Good
I
job.
got that too.
Did you? All right, anyone else get 7 and 4? Nice work.
I got 46. I got 46 bricks.
Okay, so let's keep going here. Now, here's what I would suggest. We're subtracting this 3, so this is confusing. So here's what I would do. I would say plus negative. So now you know to distribute a -3 to everything. So let's see, that's 4x plus -6x. Negative times a negative is a positive. So this is probably where some of you messed this up. Okay, this is plus 30, not minus 30. I hate it when that happens. They're stinkers when you subtract and you're subtracting this distributive problem. It's confusing. All right, this combines to -2x. So now get rid of 30, right? So negative 2x equals negative 14. So how do you get rid of the negative 2? Divide it by both sides. So you end up dividing negative 14 by negative 2 to get positive 7. That positive 7 can go right into that nice machine there to spit out your y. Y equals 2 times 7 is 14 plus negative 10 is 4. So we got 7 comma 4. All right, so that's, I think the only thing that probably messed with your heads was this dumb distributive thing here. Okay, so chicken scratch. Whenever you have this, you're subtracting a distributive problem, chicken scratch. It's going to make it a lot easier. Okay. All right, so we're going to move on to lesson 60. Back to some geometry. A lot of this will be review for you, so don't stress too much about it. So we'll kind of roll through this pretty quick. And then I think I will have like a little free, another chance for a free problem set. All right, so this is lesson 60. And we're revisiting some geometric concepts. We're talking about geosolids again. Geometric solids, or we just shorten it to geosolids. These are basically three-dimensional objects. Okay, geometric means they're able to be measured. So geometric, there's something on Earth or whatever that is able to be measured. Then solids, they take up space. So we also have a definition. I think we know what this is. A prism is, it has a polygonal base. It could be like a rectangle, a square, a triangle, whatever, but it's that same base all the way up. So most rooms, like this room, is a prism because see the floor, if all this furniture wasn't here, the floor shape, which it looks like this, kind of little jet out there, a little thing there, it's all the way up to the ceiling. See how the ceiling looks just like the floor. If I took away the furniture, the ceiling and the floor would look the same. This is a prism. It's the same shape all the way up. Okay, so a prism is a geosolid where two faces, we call them bases. So then they're not necessarily the floor and the ceiling or the top and the bottom. A base, it could be like if this Kleenex box that I used to have. Yeah, here's one. So this could be a prism. Like here's the top and here's the bottom. But you could also look at it this way, in the front and the back. Okay, you could also look at this as the top and the bottom. So the bases don't necessarily have to be the top and the bottom. The bases are just the shapes that are repeated over and over, all the way up or all the way back or whatever. Okay, are identical and parallel polygons. And where other faces, so these are the lateral faces, are parallelograms. So they have to be parallelograms, and most of the time they're rectangles. Like in this case, do you see how all the lateral faces are rectangles? But technically, you could have a prism that looks like this. You could have like a little pentagon here, and then you could have that same pentagon over here, and they're like a little wonky like this. Okay, so this is also a prism. It could be just like a Leaning Tower of Pisa type of thing. But Leaning Tower of Pisa actually leans. But see how this is still like a flat surface like that, but that is too, but the whole thing is just kind of wonky, okay? So it doesn't have to be, but look at these lateral faces are parallelograms. But when you are dealing with what we call a right prism stands upright at a right angle from the bottom. So see how this is not a right prism, because this is like an obtuse angle and this over here is like an acute angle. So it's not a right prism, but it's still a prism because it still matches this. You still have two identical faces, the bases, and you have parallelograms as their lateral faces, okay? So that's still considered a prism. It's just not a right prism, okay? All right, now here's some clues here. So this is a base, this is a base, this is a lateral face. This little guy is a lateral edge. Okay. So you see the different things, like the actual face is a face. So the lateral faces or base, those are the two types of faces in a prism. You have lateral faces and then you have bases. Okay, and then you have lateral edges where they all intersect. Okay, and this is an edge too, but it's not a lateral edge. Okay, so a right prism basically stands upright, 90 degrees. So if I did that same pentagon here, this is a right prism. Okay, so it stands upright, 90 degrees. So the lateral faces are perpendicular to the bases. This means, this little symbol means perpendicular. And perpendicular just means right angle, right? Okay, and these guys are always rectangles. See the rectangles on the sides? I mean, this is just a 3D drawing, so it looks like a parallelogram, but that's a rectangle. Okay, so look at the one on the front. It's a rectangle. All right, so a lot of that is review. You guys remember this. You may not know the actual terms and stuff, but that's what they are. Now, I'll categorize a few things here. This guy, if I did something like this, this is called a right triangular prism. So a prism is named by its base. Okay, so if it has a triangle base, it's called a triangular prism. All right, even though that's still rectangles on all the sides, right? But the bases are triangles, so we call it a triangular prism. And we call it a right triangular prism because the base is perpendicular to all the faces, lateral faces. Okay. So you know what? I mean, what's this called? How would you label this? 3 words. Nathan?
Right rectangle.
Right rectangular prism. No matter how you look at it, it could be like this, like this, like this. So when I say a square prism, I'm not talking about a Rubik's Cube. I could be, but a square prism just has a square base. But it could be, like if this was a square here, it's almost a square. This is a square prism if that was a square. It doesn't look like a Rubik's Cube, right? So that's different. That's just called a cube. If all the faces are the same, it's called a cube. Okay, now, so here's like a right trapezoid. We won't go through any of these, but now look at this. Is this the same shape all the way up? That's a cylinder, right? Isn't that considered a prism? Well, no, because A prism has to have parallel polygons. So circles have their own snobby language, okay? They don't call their distance around a circle, they don't call it perimeter. What do they call it? Circumference. They're snobs. Like we don't use the P word. We use C words, okay? They still have area, but this is not called a prism, it's called a cylinder. So this one is actually called a right cylinder. Okay, and then we just have one lateral surface that wraps all the way around. Instead of like 3 lateral faces and like 5 lateral faces, we just have one lateral face, one lateral surface. And what shape is that lateral surface? If I were to unwrap it, what shape is that? It's a rectangle. So technically it's still a rectangle. Okay. All right. And then we still have these. These are still called the bases. Okay. And then we have the altitude or height here. And that's the same for prisms as well. You have the altitude or height. And they'll usually give you that if you're trying to find the volume or surface area or things like that. Now to find the volume of all of this, volume of a prism or a cylinder, think about how many cubes you can fit on this floor, how many cubic feet, and then if you figure out how many cubes will fit on this floor by basically calculating the area, then how do you figure out how many will fit in the room? Yeah, multiplied by the height. So it's area of base times height. Area of base times height. Now in the book, you'll see this capital B. I don't like that because it's hard to remember that capital B means area, small b just means like the base of a triangle or something. So just spell it out, area of base times height. Now with the cylinder, the volume is just, what's the area of the base? How do you find the area of the base of a cylinder? Pi r squared. That's the same every time, right? So the volume is just pi r squared h, right? But it's different every time for prisms. Depends on what the shape is, what the type of prism. Is it a right triangular prism? Is it a right rectangular prism? So in this case, it would be volume equals base times height divided by 2, all times the height of the prism. So this is where the height and the height are confusing, right? This is the height of the triangle, but this is the height of the prism. That's weird. Okay. So to find the area of a triangle, remember it's base times height divided by 2. But that height is talking about this thing here. If this was like if this was the height and this was the base, right? But that's not the height of the prism. So that's confusing because there's 2 heights. So that's why they use this word a lot, altitude or whatever. So that's volume, okay? Volume's the easy one. Let's spend a couple minutes talking about surface area. Well, technically, surface area is just the area of all the surfaces, right? So if I found the surface area of this, let's see, you find the surface area of the top, the bottom, and then all these rectangles. So you're finding the area of 7 different shapes. And actually, they're not 7 different shapes because remember, the top and the bottom have to be the same. So really, you're finding the area of 6 shapes, okay? Now over here, how many shapes are you finding the area of in a cylinder? If I were to unwrap, like if this was wrapped, yeah, 3. You got the top and the bottom, which are really the same. You just double it, right? And then that rectangle that wraps around. And then you're done, okay? That's the gist of it. But let me show you some shortcuts. So in geometry, if you guys make it to geometry, we're going to talk about what's called a net. A net of a geosolid is like unwrapping it. So, do you guys ever put together boxes, like cardboard boxes? You know how they come flat? Or your parents probably made you break down boxes so you could recycle them or whatever. When you break them down, they all fold out and they look weird. Okay? I mean, technically, that's the surface area, right? That's called the net of the object. So if you were to look at it two-dimensionally, if you look at a three-dimensional object two-dimensionally, you're just looking at all the surfaces, okay? So, lateral surface area. If I did something like this, so let's see, let's do our pentagon again, which is ugly. I'm going to do a better pentagon. So let's say that here's my pentagon. Okay. And so let's say every side was 5 units long. So how do I find the lateral surface area? These are the only dimensions that I'm given. Actually, I'll give you the LSA is how it's abbreviated. But let's say this prism is 15 units high. Okay? How would I find just the lateral surface area? Any ideas? Yeah.
15 times 5.
Yeah, you could do that. So LSA equals 15 times 5. And then times, how many are there? 5, right? So you could find the area of each of these. Well, what if these were all different? What if this was like 6, that was 5, that was 5, that was 7, and that was 7. How do you find the lateral surface area of that, yeah?
Well, you could multiply each side, right?
Yeah, you could do 5 different rectangles, right? So you could do 5 times 15 plus 7 times 15 plus 7 times 15 plus 5 times 15 plus 6 times 15, and then you can ice your wrist because you just wrote a lot.
Do 5 squared times 15, 7 squared times 15, 6 times 15.
Squared. Now, why are you squaring those?
Because there's 2 sevens.
Oh, so not squared, but multiply by 2. 2 times 5 times 15. Yeah, and 2 times 7. So squaring is not the same thing as doubling it. Okay? That's an option. Yeah, you could make it easy and like say, let's just find that once and double it. Let's just find that once and double it, right? There's another way. There's an easier way.
You just multiply by 14. Wait.
So, I mean, yeah. Well, you're getting closer and closer. Eliana?
Do you have all of them together?
Yes, because look at this. If I were to figure out the net of this is 5, or that's 6, there's 5, there's 7, another 7, and another 5. So look at this, 6, 5, 7, 7. Oops. A little too much. 5, okay? So this is one big rectangle. So what is this length called? Perimeter, and this is still that height, right? So LSA of a prism, or technically a cylinder, is pH. That's it. So all you have to do is find the perimeter and then multiply by 15. Or technically, if I undistributed, so remember, like I could use the distributive property. Every one of these is being multiplied by 15. Look at that. So it's 5 plus 7 plus 7 plus 5 plus 6. See how it's the distributive property? But if you just think about this geometrically, unwrap the lateral surface. So if this was paper around that or a label, that's one long rectangle. And the dimensions are the perimeter of that prism, because that's how long that rectangle is, and then the height of the prism. That's it. Okay? So on a cylinder, same thing. So LSA is just also perimeter times height, but we don't use the word perimeter because it's a snobby circle, right? So it's just circumference times height, which is always pi d. So the lateral area of a cylinder is just pi dh. Okay? Not bad, right? Okay, should we do a free problem set? Let's see here. So here's a free problem set. Ready? Find the total surface area of a cylinder with radius of 10 and height of 10 units. Okay, so let me try to do it before you. Well, you guys know.
What's it measured in?
Just units. You can just give it to me in units.
How the answer?
Did you get it? So not quite. So that would be one of them. Not quite. Nope. Yes.
Oh, I thought you said lateral was correct.
So, you know what you did? You found the volume of that cylinder. And that is a great answer, but it's the volume. So I want you to find the surface area. Got an answer, Micah? No pressure. You don't have to do it.
I have an answer.
Yep. Good job.
I thought it said lateral surface area. So I was trying to
Yeah.
figure
So yeah, you would have gotten it right if it was lateral surface area. Anybody else?
Me.
So you found the area. Well, kind of. Yeah, you had like a weird mutation of the volume and the surface area.
Okay, I have different answer.
Close. So that's, you're a fourth right.
Alright.
So that's, now you're half right.
Did I get it? Because you were like.
Yep, you did get it. Yep, you were the first one to get it.
Okay, I have one more.
So I'm just going to draw a diagram. So this is 10 units, and this is 10 high.
I have it here.
So I want to find the total surface area, the top, the bottom, and the lateral area, right? That's it. Good job. All right. Anyone finish? What'd you get?
I don't want to say it.
All right, I'll come look at it.
I have it here in the chat.
All right, you have two numbers there. What was that, 0.64 or something? So the first part's right, so I'm going to give it to you. So the answer is just 1,256. Did you?
Yeah, I just timed it by 4 because you said I was really good.
All right. So anyone else get that I didn't see? Okay. So the surface area, remember, is the top plus the bottom plus LSA, right? And remember, the top is just a circle. So that's pi r squared. The bottom is the same circle, another pi r squared. And then remember the LSA is pi dh, because pi d is the circumference times h, which is 10. So then let's see, radius is 10, so this is 100 pi plus another 100 pi plus, okay, the diameter is 20, so pi times diameter times h. So that's basically pi times 200, so that's 200 pi. So altogether it's 400 pi. Well, when you multiply 3.14 times 400, you get 1,256, right? Was that right? 3.1, yep. Okay, so that's units, so we'd say square units. Okay, that's about it. You guys feel all right? Hey, don't be discouraged. There's a lot of pressure going for a drum set. It's just, no one wants to deal with that first thing in the morning. Okay, Elkin, so I'm gonna call it.
Black math, give me some math and I'll give you some